Have some really cool stuff going on, and we're going to get to learn about some of that today. A lot of Earth observation type stuff, which is really in vogue right now. So without further ado, here's Vivek from Vega.
Yeah, thanks for the introduction and the invitation, and I can start sharing and describing our adventures in the domain of Earth observation and applications. So some quick introduction. My name is Vivek. My background is in physics. I worked in capital markets and banks for a while, and always had a passion for aerospace. So we thought we'll start this company, launch some satellites, and build out applications. So on the sensor, our favorite sensor was and still is a synthetic aperture radar, active microwave. So a bunch of nerds who got together and said, okay, fine. So we got to lay the foundation of the house and let's field the application. So we said, okay, let's do agriculture and maritime. Okay, and so that was the start. And by virtue of many of us having a background in financial services and government and banking, we started like solving a puzzle. Okay, so you got this data. What does the farmer want? What does the banker want? You know, it becomes, I mean, very soon you realize, okay, you're not talking about going to the moon and Mars. You're talking about very pedestrian and somewhat, you might say, slightly, routine issues, because it is a business and it has to stand on its feet. It has to have a commercial traction. So who's paying? It's a very standard, classic business questions are answered. So today I'll focus on, this is just a flavor to describe, some of the work that we have done in this domain. And this particular deck, focuses on wildfire forecasting and modeling, and a presentation that we made for the NASA iTech program where we got selected recently. And to give a high-level picture, the mission statement of the company is, we provide food, energy, and national security solutions using Earth observation data sets and using a combination of AI, ML, or data-driven methodologies blended with your traditional scientific approaches. So it's not just throwing tons and tons of data at these algos, which is generating some intelligence, but have your deep physics and science-based models blended with data. So large data, you need less science, but if you have small data and you want faster computations, then you need more science. So this is the theme. And on ag, it's basically, ag is a broad word which includes agroforestry and droughts and floods and weather and climate. And wildfire sits right in the middle of it because it impacts the forestry sector. And therefore, I'll just, go through the deck and describe give you some flavor. And the topic here is AI-enabled aerospace and ground sensor grid for wildfire forecasting and modeling. Bit of a mouthful, but the idea being you're doing sensor fusion, right? So you have data coming in. It could be active data, it could be passive data. Active data could be, like passive data is just optical, like, you had reflection from the earth, you're measuring it from space, from ground, from mobile phones or whatever, and blending it. I mean, it could be crop yield, crop production, wildfires, whatever. And then active data would be synthetic aperture radar at night to pick up crop biomass. When it's, the fire is raging, you want to be able to see what's happening, and there's a lot of smoke. So to have a real-time situational awareness, you need different kind of data sources to have persistence and to have the situational awareness. So,
Are you on a different slide? Oh, there it goes.
Oh yeah, so I'm going to get started. So, oh, okay, sorry about this, yeah. Be a little mindful. So, so this deck speaks specifically about the wildfires, right? So as you all know, these, in particular wildland fires, they have a significant impact on the environment. Economic destruction, billions and billions of dollars, human health, obvious things. And off late, in the last 20 years to be specific, the frequency and duration and the intensity has increased. And a good bit of this has to do with increasing temperatures, and this is well understood, validated science, and the temperatures are rising, and this is leading to more frequent droughts, which is causing fire frequency to go up. So our job here is to see how we can impact several segments or subsegments of this wildfire phenomena. Very coarsely, you can break it into three parts: pre-fire, which means what's your predictability and accuracy of the forecast, 15 minutes before, a day before, a week ahead, 6 months, or even a year ahead. So the longer the time horizon, the more complex and sophisticated your science has to be in order to cater to the problem. So there are gaps on the science, there are gaps on the data, there are gaps on the decision support system. So this is not just projects in science, or technology for the heck of it, right? It has to be applicable to the end user, so it's operationally relevant. So in this case, the operational relevance would be for the incident commander, the FIC, units, and for land managers, and also for insurance and banking. And likewise for the during active phase, you need to be able to do the computations within 30 minutes, so it's relevant for the incident commander so they can operationally plan and manage their resources. Anyway, so this talks about the vicious cycle that we are in. You have catastrophic wildfires, you have increased emissions, you're heating of the atmosphere, and this is very intrinsically linked with droughts, right? So the more droughts you have caused by the climate change, it's a vicious cycle, right? It just goes on and on. So you want to break it. Now, this speaks about the power sector, one of the major segments that gets impacted by the wildfires. And it's a high-level diagram of how various stressors, environmental stressors, all the way from quakes, cyclones, floods, impact the various segments of the...
Excuse me, you might want to fix that typo before you take it to NASA.
The what, sorry?
A typo. Vulnerability.
Oh, vulnerability. Oh, okay. Yeah. Well, this is okay. Yeah, good catch. But this is already presented, sort of a variant of it. So yeah, good catch. I'll be mindful of that. Okay, so how do we go to the next one? Oops. Right. So what is the problem here, right? So the problem is that you don't have enough spatial and temporal data, and it's not able to keep pace or scale with the decision support for the wildland fires. So the most demanding use case would be the active phase. So and there are two subcases within this: detection and geolocation of the fire within 10 minutes of ignition. That's hard. That's a really hard problem. There could be small fires, there could be large ones, but within 5 minutes or 10 minutes, how do you do it? Because if you have LEO satellites, LEO is just, they're rotating around the Earth around 500 to 700 kilometers. They'll have a revisit of a few hours. And the only way to do this is have a geosynchronous satellite, which is sitting at 36,000 kilometers. And as persistence, it'll cover a third of the Earth. But the issue with these geosynchronous satellites is that the spatial resolution is very coarse. It could be in tens of kilometers. So you could use or try to use these military-grade satellites for missile defense. And very, very, very difficult to get a feed. Some demos have been done, but by us having graduated from the Air Force and Space Force programs, I can make an official admission. I mean, there's been some verbal assurances given to us that we may be able to procure those data feeds. But it's a public forum, so I have to be careful with what I say. But the point that I'm trying to stress is within 10 minutes of detection and then informing the incident commander. And second, being able to, and this is the holy grail of wildfire, being able to model the entire combustion and forecast how the fire will grow, and then being able to tell the resource managers and the incident commander what corrective steps to take, how many airplanes, how many fire engines, how much resources to be deployed, where, how, and when, right? So, but at this point in time, you have the numerical simulations, and some of them are data-driven. In fact, all of them are data-driven, and they take hours, if not days. So they're useful for forensics, but they're not operationally relevant. So this is the holy grail of wildfire, right? So physics and AI blended solutions. And why it's relevant to us is because this will require a copious quantity of satellite or airborne and spaceborne data. You could also have layered sensor grids, right? Like a sensing grid. You could have satellites in LEO, you could have it in MEO, and you could have it in GEO. Talking about jargon here, so stop me if you don't know what MEO and GEO are. And then also a variety of airborne platforms, which could be in HAIL or HAPS, cruising at 60,000 feet. The name of the game is persistence. Okay, so I've already alluded to this. What are the gaps? I mean, you got gaps in data, you got gaps in modeling, you got gaps in the decision support systems. I mean, even if you solve the science, your UI, UX, your front end has to be intuitive, it has to be well crafted, it has to work in the theater. It cannot be over-engineered, it cannot be suboptimal, it has to be done just right. So, I mean, there are other players, during fire phase, but in the pre-fire, not so many. So huge gaps. And then there's the third phase, which I didn't mention, is the post-fire. Because after the fire is done, there's massive debris flow. There's landslides, there's flooding, there's just destruction. And then again, you need all kinds of exotic data sets, like synthetic aperture radar for ground interferometry, for ground deformation, for flooding, and so on and so forth. So space is super central to this game. Okay, so what are the solutions? So this is a bit of a mouthful. So we are aiming to provide, I'll just read out what it's saying, right? Highly accurate fire management and decision support tools by predicting at sub-seasonal weekly all the way to the sub 10 minutes in advance of an impending ignition, and thereafter monitoring through the post-ignition phase by observing the fire growth, direction, and spread using a combination of different assets from space, air, and ground. So it's multi-sensor, multi-platform data fusion. That's the cardiac engine of this game. So how do you enable this? How do you address it? So, major, toolkits, right? So you need the data representation to lower the technical barriers. You have to automate this process, so, ingestion, pre-processing of imagery data. And then what you want to do is build up a change detection algorithm. So without a human in the loop, broad area surveillance, change detection, fully automated, right? So this is a team. So a lot of physics types, then we have operational incident commanders. So Dan and Rachel are, people in the field. I mean, a very senior, retired executive, firefighter, Dan, and Rachel is a dispatcher and with a strong GIS background. So they really helped us hone and focus our solutions for the end customer. So customer is really the king, and really I keep emphasizing this: don't build anything without having a deep feedback from the customer, otherwise it's a disaster. Okay, so then we have all these people from NASA and Dr. Mehta and big experts in climate, hydrology, so on and so forth. So we are working also very strongly with various universities. So I hope it gives you a flavor of who we are. Various partnerships, working with Washington University, St. Louis for radiology, Columbia, CUNY, NASA. We got selected by NASA HITECH. Space Eyes, it's a partner company. They have an operational system with the U.S. Navy, low latency threat detection. So and we will be using some of this. Orbital Micro, another big player coming up in the near future. They'll be launching 50 passive radar satellites to measure the atmosphere at a very high resolution, spatial and temporal, which will be a game changer for fire modeling, because you'll be able to carry out the fire atmosphere modeling at a level that is that's simply not possible as we speak. Also, Los Alamos, then Earth Daily Analytics is another partner company, placed a massive order for buying thermal, infrared, and hyperspectral data. This will help us in tipping and queuing, and so on and so forth. AFWorks, and SpaceWorks, so Air Force and Space Force. So, right. So this just talks about the sensor grid that I mentioned earlier. Like, what is the so-called grid, right? So you have satellites in LEO, which stands for low Earth orbit. You have, for persistence, you'll have GEO satellites from GEO, which is always sitting at 36,000 kilometers. We can also plug the MEO, which is middle Earth, orbit, or highly elliptical Molniya for monitoring the tundra, and Alaska, which will have high persistence. So the point being, build a platform. Doesn't matter where the feed is coming from, but build a real-time engine, right? This talks about the analytical architecture. Data feeds coming in, data processing, and then eventually information being broadcast through your mobile platforms and your web-based solutions. So this geeks out a little bit about machine learning and maintenance and so on and so forth. We've got some of these solutions, and we can bring to bear these cloud infrastructure capabilities and existing algorithms and address a variety of solutions here. What's the implementation here, right? So I've already mentioned the three major segments, of the fire: pre-fire, burn phase, and the post-fire. All three of them are grand challenge problems. So it's not one problem. I mean, there are multiple, big, huge challenges within wildfire, and another problem, which is classified under the burn phase, which I mentioned earlier, is the fire ignition detection, within 5 minutes. and then you could also extend this to impact on the supply chain, and also the pollution. Air, land, and water get polluted with smoke and so on and so forth. So vineyards get impacted, water gets muddied, so a whole host of solutions have to be addressed. This talks about some sample work that we've done in terms of droughts. Why droughts? Because droughts, basically soil moisture, which leads to the fuel moisture estimate, is your leading indicator of the fire season. So the drier the ground, the higher the chances that it's going to burn next year. I mean, it's basically fuel moisture, wind, and topography, the three major determinants. So soil moisture, until recently, it was not possible to address this because you just didn't have radar data. You need active synthetic aperture radar. NASA launched this MAP satellite for $1 billion, north of $1 billion, but it went broke, right? They launched it, and the active radar just died, 2 years ago, But they have a passive radar, so it helps. But there's a big gap here in the space community for building soil moisture focused, a dedicated fleet of radar constellation, right? It could be S, L band. So if somebody's interested, let us know, we'd be receptive. So, and just as an aside, soil moisture can give you solutions for floods, for droughts, for precipitation, for, of course, all these things like, wildfires, as well as, agriculture production, right? And military mobility. So if you want to, say for example, go to Moscow versus Baghdad, for the tank commander, you want to know what the underground, what the ground infrastructure or the terrain stability, so then you need soil moisture. Anyway, digressing a bit because this is about wildfire, but giving you the high level picture here, right? This is some work that we did with WashU, it's a radiology lab, and I'd worked there briefly, and it just goes to show the power of the software and its ability to detect, the smoke, right? So there's not any physics modeling, it's after the fact, and it's just detecting with a high level of accuracy smoke using hyperspectral data analytics. This talks about the impact for the power and infrastructure and the utility. So on the business side, right? You'll have the the fire agencies, but at the same time the power and utilities, right? They have big needs for it. So what do they need? So drought detection, advanced weather, wildfire prediction, community and first responder coordination. They need to be highly coordinated. Then AI-enabled smoke and fire detection systems and grid infrastructure handling. So through these combination of space data, airborne data, science and AI models, many of these things can be addressed. And there are many teams that are working on the same. So what are the sales targets for the company? Who are the major consumers, and who's going to buy it? Who'll pay for it? So there'll be government agencies, land managers, land management, insurance. Houses are going to be destroyed. You just need superior forecasting capability. So insurance also banking. The bonds, catastrophe bonds, they need to be priced. So it's a complex blend of what they call BFSI, banking, financial services, insurance. There's an entire segment of reinsurance. So some of us have a background in this domain, and so we understand the complexity and the intricacies behind the, how to structure these loans and how to insure them, how to hedge them, and so this is just a sample of who the potential customers are. The next one is partnerships. So this is a slide meant for working with our partners, industrial partners. So young startup companies have a big appetite for taking risks, and they can do a fast prototyping of products which large companies are unable, incapable, or unwilling. So we can definitely partner, and then large companies can give us data, and we can be fast and nimble and save lots of money and bring a lot to the game, right? This talks about some of the work that, in terms of the TRL, jargon, it's not just, some PowerPoint presentation, but actual work that we have done by ourselves and with our partners. So I've already mentioned Orbital Micro, launching 50 radar satellites. Then through another partner, SpaceEyes, we have a low latency threat detection platform that's already deployed to the US Navy. And we will be using this platform to field these different solutions for the wildfire. Then data mapping with different source providers has been done to a great extent. We've already placed orders for this in just a very, large data sets. Some public announcements to the same will be made. Some a good amount of data, models have been tested, calibrated. We have tied up with MIT. We have tied it up with, UNR, University of Nevada at Reno, which is building up a pretty sizable capabilities in the wildfire domain. Institutionally speaking, pursuing these SBIRs, and for UAVs, so we have some pretty deep expertise in UAVs and sensors by virtue of our subsidiary in Sweden. And I can elaborate on the same if somebody's willing. And different sensors, SAR, optical, IR. You need these both active and passive, and we understand this, and it's a matter of capturing the requirements and mapping the solution and then putting the right data sources to it. Okay, so name of the game, real-time intel to stay ahead of the flames. And that's basically it. So I hope it's able to provide folks with a flavor of what we are doing, what we can do, and this is very specifically in the subdomain of disaster management. So you could consider our company as a holding structure parent, which has 2 or 3, children nodes or children companies or subsidiaries. One is ag tech, ag fintech. The other is disaster management. And as you guys can see, there's tremendous commonality, right? Droughts, floods, atmospheric, impact. It'll also impact ag. And then there's an entire domain for defense. And so in defense speak, it's called ISR, intelligence, surveillance, reconnaissance. And we do claim that we can bring military-grade solutions and technology to this game of HADR, humanitarian disaster relief, and also the ag fintech. And one can go on and on for energy infrastructure, so on and so forth. But that's basically it from the wildfire front. So happy to open the floor to discussions and questions. Thanks.
Thank you, Vivek. Yes, that's very interesting. So we do have some questions. We can start with on the room. Yes.
You have mentioned high altitude satellites
Mhm.
and the Earth's orbit, and geosynchronous orbit. But there's really a high rising interest in the sun-synchronous orbit, which is like a combination of LEO and GEO together. But you have not mentioned that in your presentation. So is there a reason why you have not mentioned SSO, or have you just excluded it for right now?
No, great question. So it's a very crude classification, LEO, MEO, GEO. LEO is anything from 5 to 700 kilometers. MEO is anything from 700 kilometers to 30,000 kilometers, and then there could be MEO, there could be HEO, highly elliptical. You could customize something on your own. So the center of the gravity here is, building a multi-sensor data fusion platform, right? So if you have your super duper satellites in sun synchronous orbit, I'll buy your data. We have a deal here, man. The key is to solve the problem for the customer. So what does the customer want? The customer wants real-time intel so they can do resource optimization for the for their operations and save lives and so on and so forth. So if the data is helping me, I'm totally agnostic. Sure, yeah, absolutely, yes.
Are you paying for the data now?
Yeah, we have paid. We have bought a massive amounts of what you call the super spectral data for an upcoming constellation, and we'll make a big announcement, So, but the super spectral means, it has optical, it has multispectral / hyperspectral and thermal IR. So you'll have this just unbelievable amounts of, unrivaled data for dirt cheap. It's like an awesome deal. But so and for SAR, we're part of the whole SAR mafia, Capella, ISA, and so on and so forth. And we can get the data sources as the case may be.
So your service is basically you have your own internal AI and ML guys who do that's where you're.
Yeah. So
how many AI and ML people do you have?
So we have. A lot of us have more of a physics and a science background, So this whole AI ML is also a bit of I do regression analysis. Okay, then I'm an AI expert, So long-winded answer to your question, through our subsidiary in Sweden, 20, 25 engineers, and they're like top-notch PhDs, and I mean, they do some like big boy stuff. I mean, you want to design a fighter jet, talk to me, okay? So that kind of stuff. So and also we have 2 companies in India. We're in the process of acquiring, merging, or doing a deep JV. So there's already a lot of expertise and strength, coming in from there. But yeah, so one thing which I didn't emphasize enough maybe is the game is going towards physics-assisted AI. So you can't do this holy grail of wildfire unless you solve the real science problem of combustion modeling. So otherwise, data-driven, you can't do this kind of stuff. And then another geeky point here would be to really speed up the compute time and the communication. This has to be done within 10 minutes, right? So you can start looking at performing the calculations in space itself. So the moment you detect, have the edge processor, so you can do all the matrix and linear algebra in space. The GPO, the FPGA in LEO Geo is doing the calculations. And then it's just, blasting communicating it down directly to the incident commander.
Yes, that like domain knowledge that you bring into the AI, the physics and I think on your team you even had people that were like doing fire stuff.
Yeah. So at some point it becomes so challenging. Only a space force can actually solve a problem of this magnitude. But the way to solve these problems for smallish companies is through partnerships, right? So we partner with MIT, like the Julia Lab, right? And they've already done some work with the physics-assisted AI for wildfire modeling. And then also we're in the program with LANL, Los Alamos, and they have one of the world's really top-notch fire modeling solutions. But their issue is it's not operationally relevant. They take 24 hours to do the computation. So you have the MIT guys, you have the LANL guys, so we can work with them to field something with NASA which is operationally relevant. So my point is it's a collaborative effort. And then if I have to do the computation in space, well, we'll have to. We have partners. If we've carried out something for the Space Force and they've already done AI/ML, detection and tracking in space through in-space computing, on orbit computing. So we can also team up with them to bring to bear these consolidated capabilities so they're relevant for the chap on the ground. So it's like a puzzle, the key is to figure out what are the gaps, what do you need. Once you identify all the components of the puzzle, then you start putting it together.
A couple of questions on the Zoom.
Yeah, so we have had a question here. Which cloud provider do you use, or is it like a mix?
Yeah, so we have relationships with Microsoft. They're providing us support, and then there's also an exceptionally capable, partner of ours in Germany, and they use this DataCube technology. So DataCube is parallel computing on the database itself. I don't know much about it, but it's basically tensor calculations within the DataCube, so it dramatically speeds up the handling of the rows and the columns and. So yeah, the Earth observation game is very deeply tied with this whole DataCube technology, and they're one of the leader. They are the leaders in European Union. It's a German company. Yeah.
And we were wondering if maybe we could ask some questions about the partnerships you have on slide 11.
Yeah, sure.
Yeah. Patrick, did you have any?
This one. Yeah, this is, this happened over a period of time, over the last 2 years or so. And, for example, Space Eyes, we've been working together for many, many years. And, they're world experts in maritime domain awareness and ship tracking. And it's an evolutionary process. And now they're working with Space Force and the Indian Navy. And they've branched out into multi-domain sensing. So, they're a natural fit. Orbital Micro, again, met them in Colorado through some joint, through a conference that I attended. And now, we are looking at fielding a unified full ag fintech solution platform together. Earth Daily, we just placed a massive order with them, known them for many years. It's basically Earthcast. And so they're launching 9 super spectral satellites by next year. I went to Columbia, and CUNY Columbia, their Earth observation and environmental sciences is well known to us. I was also at WashU. I worked in I was doing my PhD in physics there. And so I just called up my own, department in radiology, and it's the same problem. I was doing breast imaging, and same thing as imaging a pimple from the space, So physics is physics, And for NASA, we just applied for the program. I mean, the iTech and just super prestigious program, and I guess we had something going for us. So they liked us, and we're in that. And AFWorks and SpaceWorks, we put in the application for OSAM, on-orbit service assembly and manufacturing. It has to do with sensor fusion AI, and so yeah, they liked us. So we're in that program as well, and likewise for AFWorks, and Los Alamos again, they also liked us, and we are and so on and so forth. And CERSIS is a small nonprofit out of Washington D.C. NASA folks, and world leaders in long-range climate modeling. So and WILDFIRE in that case is an exceedingly rich use case, because it's got everything, long-range climate modeling, weather, Earth observation, it's got all the agroforestry use cases, and then strong linkage with financial services. So, and then of course by virtue of, being selected, then you get introduced to more partners and relationships. So it's certainly an evolutionary process.
So I think NASA just launched a NOAA satellite like a month ago. It's called GHOST-T.
Oh, yes.
So do you guys ever use public data like that as part of the combination that you do?
Yeah, very, very impressive question. Not too many people know about this GHOST-T, and this satellite is actually really, really useful for us. And
It looked like a fancy satellite.
yeah, because it's a geosynchronous satellite, and we'll be able to put it to some good use. And this is still early days for us in terms of forging a relationship with NASA. It's just been a few weeks, and they want us to go stand on our own feet, sell it into the commercial markets, and then come back to them when you're attained that level of technology maturity, so it can be inducted into NASA, and they can also pay for it, right? So the first part is, to answer your question, we have submitted these 2 SBIRs 2 weeks ago, so fingers crossed, waiting for the outcome, and there'll be a bunch more coming out over the summer, and through that partnership we expect to use some of the data sources, because we'll have to conduct experiments, and we'll have to see how they're relevant in the field.
It's like a business heritage almost.
Mhm.
Space heritage.
Yeah.
So unfortunately, we have to be out here at 7, so we start packing up. But if anybody has any questions, Vivek's email is on the meetup, and you can find them at, what's the website, VegaMX?
Yeah, www.vegamx.net.
Cool. Thank you very much, Vivek. It was awesome.
Yeah, welcome. Yeah, thanks for the invitation.